guys, let's jump in. Let's talk about solving multi-step equations with variables on both sides. Yeah, that planet's there just because I felt like it. All right, let's dive in. Let's talk about moving terms across the equation. So to the other side of the equal sign. So here on the left, we've got the basic two steps. We've been solving for a while. And if I was going to solve that, I would add the 8 to both sides. Keeps the equation balanced. And I always get rid of the add subtract term first, then the multiply divide after, which is what we're doing now. The 12s and negatives cancel, and we end up with x equaling -2. It's something we've seen a lot of times. Let's look at the other side here. If I wanted to, I could think of this more as an equation where if there's a -8 on the left, and I add 8 to that left side, it does cancel out. -8 and +8 cancel. And I move that 8 over, which is what I did before. But what if I rewrite it and I just leave the 16 and the 8 separate? 16 plus 8 is 24, so it's actually exactly the same as that left-hand problem we just worked out. But we just leave the 8 separate. I want you to notice something. He was a -8 when he was at the beginning of the equation on the left-hand side of the equal. And he's now seen as a +8 on the right-hand side of the equal sign. And this is a true and always true concept or value about equations and about balancing any equation with an equal sign there. If you move something across the equal sign, its opposite value is going to be what's on the other side of the equal sign, and you'll still have a balanced equation. So if I want to think about this on the left-hand side of that equation, whatever the value was that -12x equals, I've just reduced it by 8. So if I do a +8 and cancel this out, I just increased the left side by 8 units. Now its value is just the -12x. So if I add 8 to the right-hand side, that's balanced things out. Since I just brought up the left-hand side by canceling off the -8, I can bring up the right-hand side by 8 units, and it still stays balanced. Okay? We can continue that. What if instead of solving, I just felt like moving things around for fun? What if I -16 off this side? All that's important is that I -16 off the other side as well. And I'm not going to write the -16 under the -12x because those are unlike terms. I don't want to think of combining those. I just want them to be on the same side of the equation. So now I've got a -16. I moved him over. I had the -12x there already. And I had the 8 that I moved to the right-hand side. So notice again, all we did was take a positive 16 that was on the right-hand side. And if I move them over to the left, it just becomes a -16. The equation, oh, I hate that highlighter. The equation is still balanced. I just moved the term across the equal sign by flipping its sign from positive to negative or vice versa. Okay, and we're going to do this one more time. What if I want to move that x term, the -12? I can cancel it, move it across to the right. And for all this jumping around we just did, notice what we have. We have -16 equals, I'm going to put the 12x in the front and the +8 behind it. And notice now, we moved all 3 terms, and we just have the exact same equation, but everything is flipped to the opposite side. The -12x moved across, it's now +12. The -8 moved across, it's now +8. And the 16 moved across as well to become -16. So let's go ahead and solve that guy and see what happens. We just moved everything around to different places. We flipped everything across. So now as I solve, the signs are different. I don't know if you noticed that. It used to be a -12, and now it's a +12. But when I divide, -24 divided by 12, ends up being -2. And if we notice, -2 is what we got when we solved the first time, same as what we got just now when we solved. So it turns out the equation is fully valid and equal. If I move everything across and move it to the other side, it's still a valid and equal equation as long as I follow my balance rules. Let's apply this idea and look at it with division, something dividing the x. It's still going to be the exact same thing here. If I wanted to move that +11 over, okay, or that -11, it becomes +11 to the other side. So I'm here. I now have +11 on the right. If I wanted to move the 9 over, and he cancels, it would become a +9 on the right-hand side. And it's also true with that x minus 8. I can move that entire, x over 8. I can move the entire term of x over 8 to the other side, just like any other term. So I end up with 9 equals 11 minus the x over 8. All I did was move each term to the other side, and that's true with any type of term. Okay? Let's look at this. You guys rewrite the equation with all terms canceled to the other side of the equation. So you don't even need to solve. I just want you to move those 3 and rewrite it so everything is on the opposite side, and then I'll do it right behind you. Pause me and go. Okay, let's do that. If I'm going to move things over, I'm going to go +14, and that's going to cancel, and it's going to move over with a +14 to the right. So I'm just going to put it right here. And then the 22 is positive, so we need to use a plus now. That's a good thing to point out. Notice there was nothing in front of the 22 before, but when there's another term on the same side with the 22, I need a plus now. I have to write out the positive as the plus sign for the 22 to separate it from 14. Okay? And then you can just keep going. We're going to get rid of that 22, so that can cancel over as a 22 over here. And we'll just rewrite the whole equation and save time. So now we have 7m and minus 22. I gotta watch my signs. And then we just need to move that 7m over. It's a -7m on the other side, so I now have -7m plus 14 equals -22. Now, this is kind of the longer version because I just want you guys to get the idea. Notice that each term that moved has its sign switched. So let's do the shortcut version. 7m became -7m to move it across. 22 became -22 to move it across. And -14 became +14. So if we were to shortcut and streamline this idea, watch what happens. I'm going to move the -11 over. That means he's +11 on this side because I moved him across. When I move the 8 over, it's going to become -8 because I'm moving it the other way across the equation. And then when I move that -p over 9, same exact idea, it will become +p over 9. And there you go. That's still valid, and I've got exactly the same equation I started with. I've just moved things to the other side of the equation. And at this point, you might say, what is the point of all this? Why are we bouncing things around? It's not helping us solve. Let's look at why. Variables on both sides of the equation. What do we do? Oh man, scream and run in terror. Okay. In this equation, we've got x's on both sides here. This is not something we've seen before in this class. I bet you guys have seen it before in your other classes. How do we deal with that? We need to get all the variables moved to one side. Okay, so our goal is to move all variable to one side of the equation. And we've learned how to do that with the skill we just got. So if I see a 3x on the right-hand side and I've decided I want all my x's to be on the left-hand side, I'm going to cancel the x's on the right. So 3x minus 3x cancels, and I've got a term of x's here that I can write it with. So -6, -3 is -9x. So that one step just turned the multi-step variable both sides problem into a very simple two-step equation that we already know how to solve. We just canceled the x's over to one side, and second step, I just start solving from there. And what I just did was move all my constants to the right-hand side, to the other side of the equation, which brings in step 2 here, okay? We want to move all variables to one side of the equation, and then make sure to move all your constants. Okay, that's the numbers that don't have a term. Constants are these guys, the -19 and the +8. They're terms without a variable. Move all your constants to the other side. Okay, and after that, we'll always end up in this position. Okay, now we need to solve from here. We would divide that -9 off both sides, see that x equals +3 and done. But right now, I just want you to notice, anytime you've got variables and constants on both sides of the equation, if you take one step of moving your variables to the left side, then one step of moving all the constants to the right side, you'll always end up here with a one-step equation left to finish. And it doesn't have to be variables left. It can be either side you want to put the variables. Just move the constants the other way, okay? All right, move away from each other like you and your siblings. That's what I just said. And I'm just going to point out two things here. You're allowed to go either direction with your variables, but if I decided on this equation to go to the right, I'm going to end up with what type of variable? I'm going to end up with negative variables. And that's fine. You work with negatives all the time. But if I have a choice, I think I'd rather pile up all the variables on the side of the equation where they're positive. I have less, chance of making a mistake later. So I would magically back up if I have the choice, and I would do this instead. Why not move the variables over to the other side where they're all going to be positive, and have a 20p to work with? That makes life easy. And then the other thing I'll see kids do when they're first learning this is they might do something like this. And technically this is valid. We kept the equation balanced. We just added 8 to both sides. But at this point, I think students, they imagine an equal sign. I don't know what they do, but this isn't a solved equation. And there's got to be something on both sides of the equation. -8 and +8 equals something. It equals 0. So what we actually do, if we don't move variables to one side and constants to the other, is we just create a new version of a two-step equation, and we're no closer to solving. Okay? So again, the way you want to fix that is constants to one side, variables to the other. So if I moved all the variables right, I want to move all those constants to the left, so that now I'm at that final step where I can divide to solve. And notice this doesn't come out equally, and that is perfectly fine, okay? If you end up with a fraction that doesn't divide out to finish, just leave it. My final answer is p equals -19/20. If you can reduce that fraction, reduce it. If it's improper, you can rewrite it as mixed. But this will probably happen as I give you examples for multi-steps, because it takes way too long to figure out in your head a whole number solution every time. And this is good practice for you guys anyway. All right, you try those two. Variables to one side, constants to the other, and then finish solving it. Go. All right, I'm back. I know this stuff was too easy, right? So I would first look at it and say, well, there's more negatives on this left side with the 11. So I'm going to cancel those negatives and move it across this way, just so I end up with positive m's. Now, if you went the other way, that is perfectly fine. Don't rewrite your work or anything like that. In a minute, you and I are going to have the same answer if you did the work correctly. Okay? Since I moved variables right, I'm moving constants left just to get things separated. We're right here. And what you'll notice if you went the other direction is you'll just have a positive 17 and a negative 7. And everything's going to work out to the exact same answer because our division will have one negative either way, no matter which way you solved. So we'll end up with just that, and I'm going to write it as a mixed number. 7 goes into 17 twice. That makes 2 groups of 7, or 14, that I take away from the 17. So 3 is remaining, and there you go. Okay, number 2. I'm even going to shortcut this method a little more. What if we did this? I'll add 13. And I'm going to end up with negative variables, but I'm okay with that. So I end up here with negative 6p. And I'm just going to do the same thing right on top. I'm going to do it all at one time and end up here. And it kind of shortcuts the whole method. And there we go. 6 will go into 22 3 times. That's negative 18. And there'll be 4 left over. And you could reduce that 4/6 to 2/3. But there you go. Short and quick and sweet. And now, when you put it all together, you guys can solve pretty much anything you're going to find out there. Okay? Step 1 is always going to be distribute. If you see any distributing, you need to do that first because you've got to unlock anything in that variable, in that parenthesis prison. Okay? So I'm going to distribute first. And then once I've distributed, I'm just going to rewrite everything all around it. And at this point, it should already be looking pretty darn easy. All I've got left is some like terms to combine, and then move variables to one side, move constants to the other, and you're done. So right here, I'll put my 5 and my negative 8 together. Okay, there we go. And same as always, I'm going to move variables to the right because that makes them all positive. I'm going to move constants to the left, and I'm going to do it all at once. And there you go. And if I leave that on top, that's all right. That's fine. It's still mathematically correct. Boom, there you go. You try, and I'll solve it after you in a minute. All right, step 2, I should have written in there. Combine any like terms. And then step 3, cancel any variables to the same side of the equation. Okay, I'll do 3 steps at any of these and bring it right down to solved. Distribute. Copy everything down. I don't know what just happened there. Okay, I'm going to put together any like terms. I got a bunch of bad guys and bad guys. Now I'm just copying down the rest of my stuff. Okay, now I'm on to that 3rd step. I'm going to move all my variables to the left because I'll end up with something positive. So there's my positives. That means I'm going to move all my constants to the right so that they're separated. And what is that? 13, I think. Just divide off for that last step. And there you go. All right, we got a couple more things to look at with solving equations tomorrow. I'll see you then. Go work on your homework.